Well, good afternoon, everyone. Thank you for attending the webinar on Cage-Paktors. I appreciate everybody rearranging their schedule to attend this informative meeting. Get started here. What we'll be discussing is Cage-Paktor history, the operation of the Cage-Paktors, material process, material flow, design, installation, features, results of speed changes, protection for Cage-Paktor, capacity and feed size, horsepower and wear relationship, additional options, benefits of the Cage-Paktor, application farm, and at the end, as Kim said, a question and answer session. The photograph that you're looking at is our Cage-Paktor model 2C4R. What that stands for is 2 rotating cages with 4 rows of impact. The Cage-Paktor was developed in 1962. Actually, there's some early opposed shaft models still operating down in Florida. The Cage-Paktor was to replace the more expensive machines like cage mills, rod mills, ball mills, hammer mills, impactors, and so on. The Cage-Paktor sizes by impacting the material. The Cage-Paktor was originally an opposed shaft style machine. The Cage-Paktor produces a good 99% passing 18 mesh 1 millimeter on a 50 pounds per cubic foot material.
How do you put this on speaker?
The cage mills use 2 counter-rotating cages with striking plates spaced about the periphery to impact and crush the material. Material is fed into the center of the cages and then migrates outwards towards 4 rows or more impact zones. The material then discharges freely out the bottom of the crusher. Product size is controlled by varying the peripheral speed of the cages. As material passes through each successively larger diameter row of striking plates, the higher peripheral speed puts more energy into the oversized particle than the already to size particle. As a result, the crushers allow very good control of the product top size and generates much fewer fines than other impact type crushers. In addition, since no screens are used in the crusher, no attrition grinding takes place, which is a fines generator. Wet material can be crushed without a problem since there are no screens to plug up. Trap metal protection, such as a good magnet, is needed in the feed stream ahead of the Cage-Paktor. Here's a list of materials that we have processed in the Cage-Paktor. I'm not going to read them all, but you can see that there's quite a few different types of material that the Cage-Paktor can process. As I mentioned earlier, the Cage-Paktor crushes internally. Material enters through the feed chute, past the feed ring, into the center of the cages, and the material has to go through 4 rows of impact to exit the bottom of the machine. Basically, the faster you spin the machine, the finer it makes it. Each cage is turning in an opposite direction. This is another view of the a 3D view of the entire machine. As you can see, there's no special pads for mounting, no isolation pads for this machine. They can be bolted directly to the steel structure or the concrete. Looking at this view, the material enters here, goes through row 1, 2, 3, and 4, finally exiting the machine. Each row is spinning at a faster speed. The small cage, row 1 and row 3, are turning in this direction. Row 2 and row 4 are turning in the opposite direction. As you can see, the striking plates have a unique shape to them, a unique design. This helps reduce horsepower consumption. The shaft within a shaft design allows the cages to turn in opposite directions. This is a typical drive arrangement. The Cage-Paktors are driven V-belt drive with the large motor and small motor. The shaft design also allows the variable frequency drive to be used also, and normally that's placed on the large drive motor. If the product changes or needs to be changed, you can vary the speed. The Cage-Paktor, as you can see, has a swing door on it. Very easy access to cage removal. This drawing is a typical drawing we supply with our service manuals. It's a cage lifting hook. This is what's supplied with the machine to lift and remove the cages. The drawing is basically showing what kind of distance you need and how the device works on the large cage and the small cage. There's some other photographs of the cages being installed with the lifting hook. As the Cage-Paktors get larger, of course, the lifting hook gets larger. The different pads are changed depending on which cage you're lifting. It's a very safe device, works very well with your overhead lifting hoist. Photograph showing the changing of the pads for the large cage versus the small cage. And the final installation of the small cage into the large cage. Very easy to be done with one person. Helps locate the bolt holes, and you can get in there very easily with a impact wrench and a torque wrench. An upgrade to that is an option of the cage jack. The cage jack is an integral part of the machine if you purchase it with the machine. It is a very nice device, mounted right to the machine. You can change cages out in 4 hours or less. The cage ring, when the door is closed, allows the material to go into the center of the cage and not bypass the cages. This picture is showing a 1C3R machine. This particular model is a 50-inch, which is the diameter of the large cage. The 51C3R is used a lot of times for finer or more friable material. We eliminate a row of impact. So you have one rotating cage and one stationary cage and one motor. The 1C3R also comes with a hinge door and a access door on the side so you can monitor cage striking plate wear. These are some features showing when we get into wetter applications, we can still produce the product and still maintain the speed and the product size. We'll use air cannons to help keep material dislodged. Use peripheral scrapers. We'll use a 60-degree chute, stainless steel, helps the material slide into the machine a lot better. And we'll also use possibly a liner in the inside of the machine. This photograph actually shows air cannons blasting into the throat of the machine through the feed chute. Let me back up one here. Okay. This is some typical curves. As you can see on the right side here, running the machine at 400 RPM, 600 RPM, 800, and 1,000. It's a typical product curves when you change the speed of the machine. The black line is basically your feed that you started with, and the other lines are the different speeds of the machine. These are some other curves you can see. Typical Illinois number 6 bituminous coal start with a feed on this line here, and then we just run different speeds, different increments to change the particle size. This is a typical lignite from the Czech Republic. Kind of a funny looking feed curve, but it comes in real nice after we run it through the mill. This is a typical installation drawing, suggested installation. Got some charts for the different size units. We're showing a posimetric feeder as a feeding device for the Cage-Paktor. The Cage-Paktor is basically an inefficient fan, which we need to restrict the airflow to the machine, and the posimetric works really nice. We'll have another presentation, a little bit more detail on the posimetric a little later on. But basically, protecting the machine is very important with a magnet metal detector, restricting airflow, and having the proper discharge out of the machine. Again, it's an inefficient fan, so you are displacing air. Just some other views of some of the things that are can be done to install a Cage-Paktor. This is a less expensive way to go. It's a weighted flop gate. The weight of the material opens it, but when it's not running, it helps restrict the airflow. Direction of the flow out of the machine should go in the direction of the discharge conveyor, and there should also be enough distance between the machine and the discharge device to help displace some of the air and the material so it comes out of the machine properly. It's a view of a typical drive arrangement, the V-belt guards, the flow into the machine here, proper grouting underneath the machine. Again, no isolation pads required. Some of the different ways that the drive can be connected to the Cage-Paktor. We'll send these out, and customers can choose which drive arrangement they would like. The different sizes of the machine, we have the 20-inch cage mill, and that can take up to about a 1-inch, 25 millimeter. But as you can see, the cage mill does have a slight restriction of the size material going into it. As you saw in the earlier slide, that row 1 can only take so big a material. So either you pre-crush the material so the Cage-Paktor can accept it, or you get a larger Cage-Paktor with a larger opening. So we manufacture the 20, 30, 40, 50, and 75 inch. That's the diameter of the large cage. Typical capacities you can see here: 20, 65, 135, 225, and 600 maximum. As RPM increases, horsepower to tonnage increases. Horsepower to tonnage is the same for all materials at a given cage RPM. At a given RPM, friable material will crush smaller than harder material. Product size stays relatively constant through the life of the striking plates. Horsepower tonnage goes up as striking plates wear. When horsepower goes up dramatically, let's say 20%, striking plates need to be replaced. Unit can operate at reduced capacities until time is available to change the striking plates or cages. Spare cages are recommended. As you can see, you can have spare cages sitting there available, ready to go, balanced, whether it's static balanced or dynamically balanced. They can be in the warehouse ready to go. Again, this is a picture of the way that the striking plate bolts on. This is the bolt-on design. They come in all different types of material. Some of the typical wear on the dry material, you get this as typical wear in this area, normal flow. The idea is to replace the striking plates before they get into the main structure. Again, on the left side here is the dry typical wear. On the right side is a wet brine type wear. The cage on the right is a overlay type fabricated cage. Overlay being a hard surface material on the wear surface. As you can see, the top picture is excessive wear. You probably damaged a cage when it got down this far. The second one should be replacing them. Your structural, that this is bullet tube, is starting to become exposed. The last one is the new striking plate, which is a gauge. Basically, when you start up a machine, you should monitor the wear. Some of the options are ceramic lined feed chutes. If you have some real abrasion material, this works very well. Another option is a common base. Common base would support the machine, the motors, the guards, and any other lubrication system, disconnects, any other thing you might want to purchase with the equipment. it also helps us control where the drives are located. And not all the time, but sometimes these can all be lifted up in one section, depending on the size of the machine, and put in place, and it makes for a real nice package. The optional fabricated cages were developed to have a cage that was a little more forgiving if you get a non-crushable in it. The other cages, the bolt-on type, are very good cages. They're just not as forgiving if you get a non-crushable in the machine. As you can see, there's an overlay material on the striking plate itself, and these cages are rebuildable. I was talking about this a little bit earlier, a stainless liner, a rolled liner inside. This was going to be a real sticky application, so we had the roll liner, scrapers, air cannon ports, and was working very well. A couple other things can plug up a machine is wood. Sometimes that can get in there, and our larger lumps, we can put in a breaker bar, which is a stationary arm that's attached to the feed ring. When you close the door, it stays stationary and the cage rotates around it. It acts as a breaker bar, scraper, whatever you want to call it. It works very well. Again, that is an option if it's necessary. This isn't very pretty, but this is what happens when you get a non-crushable in the machine. You can break the striking plates, break out the structurals, and have a lot of parts down on the discharge chute. So protecting your machine is very important. We also have rebuilt shaft assembly. We can rebuild shaft assemblies in our facility, and it is recommended to send those in and have them rebuilt. They are very difficult to rebuild at times. When the machine fails, all the tolerances have to be checked. So we rebuild it, we test run it, and ship it out with a manufacturer's warranty on it. So the benefits of the machine are basically no screens or grates, open bottom, selective crushing, replaceable striking plates, special design striking plates to reduce horsepower consumption, better yield and controlled product sizing, ease of maintenance with the drive on one side. You can install a VFD if you're changing the particle size a lot. Can perform with wet materials. This is a typical inquiry sheet or an application sheet. This is some of the typical information that is required to size a machine. So if any applications come up, we'd like you to fill it in as much as possible. If you have any questions, particular applications you'd like to share with us, please complete the form and submit it to us. With that, I thank you, and if there's any questions, feel free.
Hi, Phil, before I unmute everybody's lines, which I'll do in just a second, we did get a couple questions through the Q&A. The first one, is the lifting hook supplied as standard?
No, it is an option.
Okay.
Or I'm sorry, you're saying the lifting hook?
Yes.
Oh, okay. I'm sorry. The lifting hook comes with the machine.
Okay, and everybody is off mute now, but I do have one other question that I'd like to read to you that came through. It says, please provide information on mean time to repair and mean time to fail or expected maintenance requirements. Also, please provide accessible information. And actually, it just came through. If that's a whole lot, you can send that information to email, and I can give you that email address.
Yes, I'll send it via email. But that lifting hook is standard. It's supplied with the piece of equipment.
Hey, could I ask a question, Phil?
Yes.
What type of seals do you use on those shaft, the internal to the external shaft on the bearings?
That's a series of labyrinths with grease.
Mm-hmm.
At times, we have supplied a special seal on there, but the standard seal is a series of labyrinths.
Oh, okay. We've noticed that we get a lot of heat buildup with a lip type seal on those.
Yeah, we don't have a lip seal on there.
Okay.
Yeah. Like I said, we don't want the machine to have positive pressure in it. We want to, take the material away as fast as we're putting it in there. We don't want it to build up any pressure inside the machine, causing the seal to have excess pressure.
Okay.
Phil, this is Gene Bramall. It looks like the whole bottom of the machine is open.
That is correct.
Across the whole bottom of the machine?
That's correct.
And I understand the need to have a way for the air to exit, too. I still think, though, even though you've got scrapers and you put some stainless around, there's probably at some point build-up, depending on the material itself, build-up could create an issue and or reduction in capacity?
No, because normally if you open up a machine and it's got some buildup in it, the exit section is open.
Okay.
You may have a little bit stuck inside the machine towards the outside, but that's what the scrapers are for, to keep it away from that. If you wouldn't have the scrapers on there, it would build to the cage, and the cage would become a break, or the material would become a break.
Okay. Well, I've just seen in the case of, let's say, roll crushers, even though you have some very large exit chutes, I've seen some materials bridge across the whole exit chute and, trap material in the machine. I guess the cage mill is maybe a little better fan, keeps it clean, huh?
It does, and like I said, your distance from your discharge device is important. You don't want your discharge device right up underneath the machine because, again, it'll cause a vortex and everything. You'll start redigesting the material, or it'll start sticking to the walls of that discharge chute.
Okay. Thank you.
Phil, I have another question in the Q&A feature here. It says 6-inch feed in the 75 CP unit. What's the reduction ratio?
Well, again, it depends on the speed of the machine, but we can take the material down to, depending on the hardness of it, we can take it down to approximately the quarter-inch area. It varies on the hardness of the material.
Do we have any other questions?
Yes, this is Brad Schreiber calling from Pittsburgh. Hey, Phil, I was wondering, I know this requires friable materials there for this impact, but what is the hardest material or resistance to impact that that we've been able to successfully crush with the cage mill?
Well, usually we've done coals, 5,000 psi to limestone, 15,000 psi. We've done glass in it before, which your wear life isn't real high, but we've done those kind of materials before too.
Okay, thank you.
Any other questions?
Phil.
Just one question. Before you got hooked up with TerraSource and had access to the posimetric feeder, the previous recommendation would have been a flop gate style?
Yes, it was. That's an inexpensive way of doing it, but the posimetric would work very well for that. It does need a head of material on it in order for it to work properly, but it also creates an airlock in there too, and it gives the machine a nice steady flow.
Phil, I have a question.
Okay.
Okay. I was just curious. If you have an application, this is Paul DeVitas. If you have an application or you have something out in the field, and let's say it's making a finer output than what you really need, do you ever get into a situation where what you do is just shut off, let's say, one row of the cages or two rows of the cages and make those stationary and leave the other two rotating?
No, that would cause a plugging situation because we'd be stopping two rows. What we normally do is we'll recommend a 1C3R machine, but it would reduce some flow to a point, and again, our spacing between the striking plates have been engineered for years to give maximum flow through the machine, each model. But that's one of the reasons why we went to a 1C3R, because the 2C4R, 4 rows of impact, was definitely doing that. We had to run it so slow that we were losing efficiency with the 4 rows.
Hey, Phil, this is Mike.
Yeah, Mike.
What he may be referring to is when we got the machine, we were trying to make it coarser. Up at East Chicago, we actually cut row 4 out of the machine and made it a 2-cage 3-row. We wouldn't, as you said, stop a cage, but we would cut cages out, or cut strikers out.
Yeah, we did that on a couple of occasions.
Yeah.
Or could you just, let's say, go in and put in every other row of striking plates, or is that not an option?
We did that with one in South America where the feed was bigger than we thought, and we cut every other striker plate out. But you have to be careful because it starts changing the profile of the curve.
Yeah, I'm sure it would, yeah.
Any other questions? No, Kim, I guess that's about it.